Hey everybody, tonight we're trying to find the minimum value of a trigonometric quotient without using calculus. That means don't take derivatives, don't find horizontal tangent lines. Now, you guys are familiar with this interval notation. It means the very same thing as saying all the x values strictly between minus pi over 2 and pi over 2. And of course, that's the same as minus 90 degrees and 90 degrees. Now, the only reason that I'm restricting the domain is just kind of easier to focus on the problem. And also, cosine happens to be positive in that interval. Those of you familiar with trig, it's very easy to sketch. You know what cosine looks like. From 0 to pi over 2, that's cosine. That's pi over 2 right here. And also, cosine is an even function. It's symmetric about the y-axis, the vertical axis. And so, since that symmetry will give you this look right here, sort of, not really to scale. All right, but that is the cosine wave. And so this is cosine x in that interval, and it's strictly positive, or yeah, it's strictly positive in that interval, okay? Now that ends up being important as far as the approach we're using here. Well, let's go down and take a look at that approach. Now, notice that since cosine x is strictly positive, we can cancel it. You know, it's never equal to 0. We can cancel it and get this statement. Now, this statement is this particular equality, or this equivalent formulation of this quotient is very amenable to a very well-known identity called the geometric mean, arithmetic mean inequality. And it assumes that the variables are non-negative, I think positive. So this result here, the arithmetic mean, a plus b, divided by 2, is greater than or equal to the geometric mean, which would be the square root of the product. So it's fundamental in the sense that it relates the operations of addition and multiplication. Okay. Now you can see why that's useful here, because we can the left-hand side looks sort of like this without the 2, right? And so now y'all, equality occurs right here whenever a is equal to b. It's not really that important to us for this problem, but equality occurs when a equals to b. Now, and I'll say this briefly. There's a 2 right here. This thing could be extended. That's the index of the radical. If you said a plus b plus c over 3, this would be the cube root of the product a, b, c. Okay, so that's how you generalize the arithmetic mean, geometric mean inequality. All right, but anyway, that's what we do. Now, y'all, I made it green for you. I made it green for you just to track everything. All right, so this is just applying the arithmetic mean, geometric mean inequality right here, okay? Now, we don't get quite what we want because we're dividing by 2, but if you multiply through by 2, you get this statement right here, okay? And this is what we're interested in, okay? I didn't keep it green right here, but in any event, this is the object. This is equal to what we were interested in looking at if you go all the way back up here, right? Okay? So notice right here, because cosine x is strictly positive, the cosine x cancel. And so this part right here is just equal to 2 times the square root of the square root of 80. Okay? And again, y'all, these cosine x cancels are strictly positive. And then 8 times 10 is certainly 80, right? But so, folks, this is the very same thing as 2 times the square root of the square root is the 4th root. Okay? Okay, and then what's going on there, folks? Well, this is 80 does have a perfect 4th power, namely 16, so we can write this as 2 times the 4th root of 5 times 16. Okay, and The fourth root of 16 is 2, folks, so this is actually equal to 4 times the fourth root of 5. And y'all, this will be our minimum value in that interval, okay, fourth root of 5. So that's the minimum value because, again, it's greater than or equal to this number for all x in that interval, right? Now, I didn't explicitly write that, but so this is the answer right here. This is the minimum value. Okay, this is the minimum value of this expression somewhere in the interval. Now, so we're done with the problem. This is it. This is the answer. The 4 times the fourth root of 5 is the solution. Now, you can ask more questions, but you won't be able to answer them very easily if you're anything like me on this stuff. Now, you'll notice, again, we never use calculus here, but we know that this function can never get any smaller than 4 times the fourth root of 5. Okay. Okay. Now, for the more curious of you, you can, to know when this happens, you would actually have to equate this. Let me just write this down. Root 10 cosine x. Remember, the equality condition actually occurs when the two input arguments are equal to each other. Okay, and so that would be when root 10 cosine x is equal to root 8 over cosine x. Okay, yeah, but notice that this implies that cosine squared x, if you multiply through by cosine x and then divide through by root 10, cosine squared x is equal to the square root of 8 over 10, which is less than 1, which you would have anticipated, I think. Now, y'all notice this isn't a so-called nice number. There would be 2 answers to this that would correspond to this minimum value. I don't have any idea how to find this without just numerically doing it or using Newton's method or something. This isn't a nice angle at all. In fact, what is this, folks? This is equal to 2 root 2, right, over 5 root 2, right? Or, yeah, the square root of 5 times the square root of 2. But you see, this is definitely not one of the so-called nice numbers or values, nice angles, or not angles, but you know what I mean, radical expressions that come out to something like pi over 6 or pi over 4. But notice the root 2 over root 2 cancels, and so you get 2 over root 5. And again, I have no clue how to do this other than using something like Newton's method, which involves calculus, of course. But that's just a side note. So you would get plus and minus versions of this, and then you'd have to find the angle. Who knows? I have no idea. Taylor series, something, I don't know. But in any event, this is the final answer. We did it without calculus. Hope you enjoyed.